All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we went over was what would happen if we wanted multiple different outputs for our neural networks. And tonight, we're going to pick up where we left off. So, what might a case be where we want multiple different outputs for our neural network? Well, we might consider that in the case of weather predicting, for example. We might not just care about whether it's raining or not raining. There might be multiple different categories of weather that we would like to categorize the weather into. With only a single output variable, we can do a binary classification, like rain or no rain, for example, 1 or 0. But it doesn't allow us to do much more than that. With multiple output variables, we might be able to use each one to predict something different. Maybe we want to categorize the weather into one or four different categories, something like raining or sunny or cloudy or snowy. And we now have four output variables that can be used to represent maybe the probability that it is raining, 1 second, as opposed to sunny, as opposed to cloudy, as opposed to snowy. How then would this neural network work? Well, we have some input variables that represent some data that we have collected about the weather. Each of the inputs gets multiplied by each of the various different weights. We have more multiplications to do, but these are fairly quick mathematical operations to perform. And then what we get after passing them through some sort of activation function in the outputs, we end up getting some sort of number. With a number we might imagine we could interpret as like a probability that it is one category as opposed to another category. So imagine that we are implying that based on the inputs, we think there is a 10% chance of it raining, a 60% chance of it sunny, a 20% chance it's cloudy, and a 10% chance that it's snowy. And given that output, if these represent a probability distribution, well, then we could just pick whichever one has the highest value, in this case, sunny, and say, well, most likely we think this categorization, the inputs mean that the output should be sunny, and that is what we expect the weather to be in this particular case. So it's saying that if this was something like a probability distribution, we would pick the state with the highest probable chance of happening, which would be a sunny day because there's a 60% chance of it being sunny as opposed to the rest of the states, with its 10% chance of raining, a 20% chance of cloudy, and a 10% chance of snowing. That's what that means. And so this allows us to do these sort of multi-class classifications. Instead of just having a binary classification, 1 or 0, we can have as many different categories as we want. And we can have our neural network output these probabilities over which categories are more likely than other categories. And using that data, we're able to draw some sort of inference of what it is that we should do. So this sort of, so this is, so this was sort of the idea of supervised machine learning. We can give our neural network a whole bunch of data, a whole bunch of input data corresponding to some labels, some output data, like we know that it was raining on this day, we know that it was sunny on that day, and using all of that data, the algorithm can use gradient descent to figure out what all the weights should be in order to create some sort of model that hopefully allows us a way to predict what we think the weather is going to be. But neural networks have a lot of other applications as well. We could imagine applying this same sort of idea to a reinforcement learner sort of example as well, where we remember that in reinforcement learning, what we wanted to do is train some sort of agent to learn what action to take depending on what state that it currently happened to be in. So depending on the current state of the world, we wanted the agent to pick from one of the available actions that is available to them. Now I'm going to leave it there for the night. I'm not going to do too much reading. We did take a lot of notes and we did dive a lot deeper, but I'm not going to pick up too much into it because we still have a long way to go. But I will keep you guys posted every step of the way, and we will pick it up tomorrow night. But as always, it's the Python Papi. You guys stay Gucci.